As I promised you last class, we were getting into time value money, and it's hard. It's really hard to comprehend or really visualize time value money without doing actual examples. So today we're going to do two problems from your Excel application set. You have 5 problems there. We'll do one that's a present value problem, and we'll do one that's a future value problem. And that will set you up to be able to do the other problems. So today, really focus in on understanding the concepts. You don't need to memorize a lot of formulas. There's a few formulas you need to just know, but they're pretty straightforward because it looks like there's 4 formulas, but there's really just a couple, and they're somewhat algebraically the same variants of each other. So the key is concepts. Understand the concepts. We'll also build this in Excel, and you're going to find these problems have a lot of practical applications. So it's not something you do just for the class, but something that you keep and remember into the future because it's quite valuable. Some of this we'll actually be using in other parts of the class later to do very similar types of things. So we're going to spend this class entirely in Excel. And so what I want to do is first let's look at the formulas. The first 2 formulas you do not need to memorize. So if you're a finance or accounting major, there's times I've had these formulas memorized. There's other times I can't remember exactly where the parentheses goes, but these are formulas you can usually look up if you need to. They're probably in Excel. We're going to build them from scratch because later in the class I'm going to show you mathematically, especially on the present value one, how we derive these formulas. And I think conceptually it's actually quite powerful to see how we actually come up with these formulas. So these 2 formulas we are going to build in Excel. So we'll put it right here. We're going to put the present value interest factor of an annuity there and the future value interest factor of an annuity there. And I'll explain what each of them mean here in a second. These other formulas are formulas that we'll probably use at some point or the other. I'm going to move this over a little bit just so we have a little bit more room. So this present value, what it's saying, present value means what is something worth today. So PV is present value. Present value equals what something is worth in the future discounted today. How do we discount it? Well, we take that future value and we divide it by 1 plus our discount rate. In these set of exercises, I just give you the discount rate. In future exercises, you'll have to actually come up with the discount rate. For here, I'll just give it to you. Raised to the n. All right. This one is this is a pretty rarely used. In fact, we may never use this formula in this class. This formula by itself. We're much more likely to do the present value interest factor. What's the difference? Well, the present value interest factor of an annuity is when you have multiple cash flows that are the same cash flow are growing at some rate. So a good example that we're going to see is a loan payment. You've got to pay a loan that say is $1,000 a month for the next 60 months. The present value of that is the price of the thing that you're buying with the loan. And so that's a really, it's a loan amortization schedule. So this is what we do for loan amortization, which is what we're going to do today. Build a loan amortization schedule, and you'll see how that works. So this one's the same thing as the future cash flow that we're discounting to today, but it's rare that you'll just have one future cash flow that you want to put in today's dollars. So it's very rarely used. The present value equals the payment times the present value in annuity. This is, again, going to be used to give us a loan amortization schedule. So how do we do that? Well, the present value is the cost of whatever you're doing. So let's say we're buying a car for $20,000, then the present value is $20,000 equals the loan payment. You can think of this as a loan payment times this factor. So the present value interest factor annuity is used a lot anytime you're borrowing money because it's either going to tell you what your loan payment is. That's what we normally do. We know the price of the car. We just want to know the loan payment. So that's the most common application. It is possible that you can say, you know what, I could afford a $700 a month car payment for 5 years. How much of a car can I buy today? In that case, you would put the $700 times whatever factor you got here, and that will tell you how much of a car you can afford today. this next function, the future value equals the present value times, in this case, we know what something is today, and we want to know what that will be worth in the future. Now this one we use a little bit. What we're doing here is usually we're trying to deal with inflation, and you'll see that actually in our second problem that we're going to do today. So I'll wait and save that there. It's not used very much. It's used a little bit more than this, but this is something where you think, okay, this costs $10,000 today. Inflation, I think, is going to be about 3%. So if I wait and buy this in 10 years, how much will it cost in 10 years? So you're trying to take something that you know what it costs today. You have an idea for the inflation. You want to figure out what will be its cost in the future. So that's a future value problem. These, the future value interest factor annuity, these are usually retirement planning. You want to build a portfolio. You're saving money. And so what we want to do is say, okay, I'm going to invest $500 a month until retirement. How much will my retirement plan be when I turn 65? So you'll use this factor here. So that investment times that factor tells you how much you'll have in the future. So we'll definitely use that. The ones we're primarily going to use, we're going to build these two. So we'll build those. So you'll have them on the exams. I'll give you these numbers, so you don't have to worry about memorizing these formulas. We're going to build it right now. If you can keep up with me on these, and I'll go slowly. Keep up with me on building these formulas. Then you'll have whatever you need. I recommend you build them and put them in every problem, and then all you have to do is ask, is this a present value problem or a future value problem? But you always have the factor there, and you can easily manipulate it. So let's try a problem. Before we do that, let's just put in some numbers. The two numbers we need are a rate, that's the I in the formula, and we need time. That's the N. And remember what we said last class, the I and the N need to be on the same basis. So if the rate is 6% annual and your time is 5 years, then 6% and 5, that's consistent. You're going to say you're going to pay a loan once a year for 5 years at 6% interest, then the 6% and the 5 would make sense. But let's say you're going to pay the loan not annually, but monthly. So then you would take, and look at how I'm doing this, then you take the annual rate, the 6%, and divide it by how many payments, how many times during a year you're going to make your payments. So here we're going to do it monthly, so there's 12 months in the year. So that means our monthly interest rate is 50, all right? Let me insert some here. So here what we're taking is equal 6% divided by 12. That's what we're doing to get that 0.5. So we have the annual rate and we divide it by 12. And so in the years, what do we do? Well, it's 5 years, but we're going to make monthly payments. So here we have monthly interest rate and we have the number of months. So here we're going to do equal 5 times 12. All right, so to get the rate, you take the annual rate divided by the number of payments in the year, and on time you take the number of years times the number of payments in the year. So you'll be paying 0.5% per month, which is 6% per year, so 0.5% per month for the next 60 months. All right. Now you try this. What if this was weekly? What would we do? So pause the video, rather than me pausing here. Hit pause on the video and you work it out. And then when you hit go again, I'll be going. All right, so for weekly, we're going to do 6% divided by, well, how many weeks are there in the year? Well, about 52. Right? If you take 365 days divided by 7 days, you get 52.14, but we can just say 52. So we take 6% divided by 52, and then how many weeks is that? 5 times 52 is 260 weeks. All right. So let's set this up with this formula. So look at the formula over here, and we're going to type it exactly like that formula. So we're going to do equal, and the only thing is we can't use the brackets. We can only use parentheses, but we'll do equal, open parentheses, 1 minus 1 divided by, you have 2 parentheses there, 1 plus our rate, close parentheses, raised to our time, close parentheses, divided by the rate. Now in the present value interest factor annuity, what you'll notice, we usually go 4 decimal places. What you'll notice is it will be lower than the n. On present value functions, the present value interest factor annuity is going to be less than the time. The only way they'd be the same is if your interest rate were 0. If your interest rate were 0, well, the formula doesn't actually work. But if the interest rate were 0, the factor would just be 260 because there's no interest impact. All right, so there is that formula there. What I'll do in Excel is make sure you have what I'm typing next to the cell so you can see it. So what I type there is exactly that. So if you're not getting that, then hit pause. You can see the formula like that if you want to, or you can see it next to it. So hit pause and keep trying until you get 224.5132. Now it's a little more than that. It goes on many more decimal places, but we usually go out 4 decimal places because we're using dollars and cents. And so our rounding only needs to go out 2 decimal places. So if we take our factor out 4 decimal places, then it will keep us from having any serious rounding problems. All right. So hopefully you've got that set up and working. Now if you hit pause, you can catch up with me there. But there you see the formula. So now let's try the future value function. This formula right here. So here we're going to do equal, open parentheses, you notice there's 2 parentheses there, 1 plus our I, close parentheses, raised to our n, minus 1, close parentheses, divided by the I. And here we'll know we probably did it right if we get something more than 260. And here you see we got 303. All right. So see the function. I'll highlight it again. If you need to hit pause, if you're having trouble if you're not getting an exact number, it's probably a parentheses problem. That you don't have your parentheses in the right place. So make sure you get your parentheses exactly how I type it here. I know in the formula I have some spaces just to make it easier to read a formula, but you can't have any spaces. Everything has to be right together. All right. Hit pause if you need more help. Otherwise, I'm going to show how we're going to actually implement this. Okay, so what I want you to do now is highlight everything from A1 through C4 and hit Control-C and go to the next page on go down to line 10. And the reason I say line 10 is I want to give you room to put these problems in here. We'll set this up a little bit. So this is actually your first problem. So let me show you a little trick here. You notice how I have all of these cells are merged and centered, and there's a way to do that that's real simple. If you just go to what you want to combine and you press the Alt key and HMC, it will merge all those cells together. So watch there, I've got that highlighted, and Alt HMC, and see how it brings it all together. I don't want that here, but if you want to do that up at top, Alt HMC, and then go over to your Excel applications and problem 1 and copy and paste it. So I highlighted A1 through L8, and I copied it and I just pasted that problem number 1 at the top there. So if you want to do that, that's fine. You don't have to do it that way. You could do a snip and just bring the picture of the problem over if you wanted to. That would work just as well. But this is the first problem. But Alt with the HMC lets you center stuff. It's really pretty cool. I use it all the time. So it's pretty cool. Now you may have to do a little bit of more centering here. I probably should get one extra step here. If you do format cells, I like to do the vertical center as well as the horizontal, and I'm not sure how to get the vertical to center, so that you may have to do yourself. Make sure you have wrap text on there so that it wraps it. But the other approach is obviously you can just do a snip and just copy and paste that into Excel if you like. So either is fine. You can put that up on top as well. So either is fine. If you do this, you'll have to shrink it a little bit. So however you feel most comfortable doing it is fine. We got the problem in there, all right? All right, so we got this guy named Jumbo. He wants to buy a luxury car. He will pay the loan back. So you see that word loan? That's really important. So we're talking about a loan. Remember I said that loans are present value problems. So this is probably a present value problem. He's going to pay the loan back over 5 years through a bi-weekly deduction. So there's 26 payments, all right? So 5 years. What does that mean? So equal 5 years times what? How many payments a year will he make? He will make 26 payments a year. So let me expand this a little bit. You don't need to do that. I'm doing this just so you can see it better. All right, so we're going to take 5 times 26 because it is the number of bi-weeks. So this 130 should be the total number of payments that he is going to make over the life of this loan. So he says 5 years and 26 payments per year. So that's 5 times 26. 5 times 26, and so that tells you that gives you the 130. Now what is this rate? The car he's looking at? All right, so let's take the target. The target is going to change. The target on this car is $78,000. So we're assuming no down payment or anything. If I gave you a down payment, you would subtract that because this is how much we're going to borrow, $78,000. The bank is charging an interest rate of 5.72. So let's take that 5.72%. What do we do here? It's bi-weekly, so we divide by 26. So we're going to do equal 5.72% divided by 26, and that gives us 0.22. And you notice our formulas down here have automatically updated that. So we don't have to redo these formulas. We did these previously, so we already have those set up. So everything's ready to go. Put it on pause if you have any issues. I've got the formulas here on the side. I'm not putting the formulas for these two over there because we did that on the previous page. So if you're not getting 112.9552 or 150.3065, I'm not sure what you did. You should have just copied these 9 cells, copy them, Control C, and all you have to do is hit enter. After you hit Control C, just hit enter in A10, and it should bring it right over. So that should be there. All right, so now we got to figure out. We're going to now use this formula here. I'm going to bring this over. You don't need to bring this over, but this formula here says that your loan payment times the present value interest factor annuity will equal your target. In this case, we know that the target is $78,000 is going to equal the loan payment times the present value interest factor of an annuity. So what's the one thing we don't know? Well, we know the present value interest factor annuity is right there. We know the present value is right there. The only thing we don't know is the loan payment. That's the piece we're trying to figure out. All right. So let's set this up, and this is really critical right here. So I'll slow down a little bit just to make sure everybody's with me. So when we do an amortization schedule, this is an amortization schedule. We have a starting loan amount, and we're going to pay it down. So after 130 weeks, there won't be anything left. We'll have paid off the entire loan. So to do that, we're going to have a few columns here. The first column is time. All right, so put that down. I'm going down to line 17. I would do the exact same rows I'm using just to make sure the formulas are exactly the same. So you have your rate in line 10, your time in 11, your two factors in 12 and 13, and then your target in 14. And then I'm going to start this table, time on the first one. We're going to do beginning balance in the second column, in column B. The next one, we're going to have interest expense. The next one, we're going to have the payment. And the last column we'll have is ending, our ending balance. All right. Now I'm going to change these columns. I'm going to make them, I'm going to do column width. Let me make them 15. It's going to a little bit mess up the problem, but that's okay. We don't really need the problem anymore. So sorry, there's a little bit of Bill Gates going on here. Let me reformat this to the bottom just so that you can see it. Let me format it to the top. Maybe that's the problem. Here we go. All right. So let me do all these columns. I think I said 15. So there's our columns. So the other thing I'm going to do is highlight them all. I'm going to hit the center button here and the bold, so it'll have nice looking columns. If you want to color it in some, that's always nice too, just so you have a nice title. All right, so remember these 5 columns, because when we do a future value problem, we'll use almost the exact same columns but slightly different titles. All right, so on time, here we're doing how many bye weeks are there. We'll start with time 1. So in row in A18, put 1. That's your first bye week. And then in 19, you'll do equal A18 plus 1. All right. I'll put that formula up at the top so you can see it. So equal A18 plus 1. All right, the next column is the beginning balance. All right, so what is your beginning balance? For our beginning balance is $78,000. That's our beginning loan. Now, that's the difference between a loan with a present value problem and a portfolio, a future value problem. With a future value problem, our beginning balance will often be 0 because we just started. We started building our portfolio. So we're going to see some differences, but for the loan, your beginning balance is the amount of the loan. Now the interest expense, see here I just did equal B14. See that, equal B14. Now for interest expense, our interest expense is going to be our beginning balance times our rate. Now for the rate, we need to lock that in. If you're on a Windows machine, you can just hit F4 On an Apple, I think it's Command F4, but I'm not absolutely sure. But if you can't get that to work, what you need to do, you can manually type a $sign. Reason we're doing a $sign is we want to copy this down. We don't really need a $sign B, but we definitely need a $sign 10, because the reason we want to do that is we always want it to be row 10. We always want it to be this cell, B10. That's always the rate. If we copy it down and we don't do this, then it's going to go to the 130, then the 112, and we'll get just ridiculous numbers. So we always want to multiply it by 0.22, so you need to lock that in. You can manually type in the $sign B and the $sign 10 if you like. The B18, we want that to go down as we copy it down. We want it to go to the line 19, then 20, then 21. All right, so that's what we're looking for there. So you should get 171.60. All right. So hit pause if you ever have issues and something's not working. Now the payment, we want to make the exact same payment every 2 weeks. So what is our payment? Well, remember this formula right there? That's our payment. So what is our payment then going to be? Our payment is going to equal $78,000 divided by the present value interest factor and annuity. So if you do the algebra, you bring the loan payment over there to $78,000 over there. So $78,000 divided by PVFIA equals the loan payment. So let's put that in there. You take the target, the loan amount, divided by the present value interest factor annuity. Now you notice I'm not hitting the lock-in formulas here, and I'll show you why on that when we get to the second cell, to the next cell. So here you notice it's several decimal places, but we know this is a dollar amount, so I'm going to click on the dollar up here. So there's that formula. You should get 690.54, and it's going to be 690.54 all the way down, so we'll fix that when we come to the next one. Then on the ending value, let me move this up. On the ending balance, this is another difference between this and the future value problem. With a loan, you start with your beginning loan balance. You have to add the interest expense, but you subtract your payment. And that shows you what your balance is going to be. Sorry, let me get these all the same size. You don't need to worry about the sizing. I'm just doing it to make it a little easier to see it on the video. All right, so there's your ending balance. Hopefully you're getting 78,481.06. You got the formulas up there. If you're in the exact same rows I am, your formulas should work great. All right, so then we'll come to the next row. And what is your beginning balance? Well, your beginning balance the second time around will be your ending balance from the previous one. If you like, you can hit the dollar sign there so everything's in 2 decimal places. So your beginning balance there is referencing your ending balance back there. Just E equal E18. I don't have any place to put it. I should have put an extra row there, but equals E18. So make sure you have that down. My interest expense, the nice thing here is I can just drag it down. So you see that little square in the corner there? If you grab that square and just bring it down, it will bring it down. So you notice your interest expense is dropping a little bit because your balance is dropping a little bit. All right, so all I do there is the same formula, I just copied it down. So there's nothing new. So instead of being B8 times B10, it's B18. It's B19. Why? Because we didn't lock in the 18, but we did lock in the B10, so you should have B19 times B10. Now the payment's always the same. So here we can just reference the previous cell. Just do equal D18. And so that payment's the same all the way through. And then on the ending balance, again, we can just copy it down. And there's your ending balance. So right here, make sure you have an ending balance of 76, 960.98, and if not, go back on the video before you go any further and make sure you have all of these formulas. All right, so the beginning balance was our target. The interest expense is the B18, that beginning balance, times B10 with B10 locked in. The payment is your target amount that you're borrowing divided by your interest factor, present value interest factor, and annuity. Your ending balance is beginning balance plus interest expense minus payment. When we do the future value problem, we'll be adding all three of them, but here we subtract the payment. The next period, your beginning balance is your ending balance from the previous period. Your interest expense, you just copy the formula down from above. The payment, you actually reference the dollar amount above. Ending balance, you do beginning balance plus interest expense minus payment. Here you notice we just copy it down. We didn't lock anything in because we always want it to go down. So that gives us 2 periods. How many periods do we need? We need 130. So if line 1 was on line, if period 1 was line 18, then period 130 should be something like 147 or something. So the way I'm going to do this, if you do control, so let me, just in case some of y'all are not Excel users, go to cell A19, do control shift, hold those two down together, then hit your right arrow key, and that will highlight all of that. And then what you can do is just grab this corner and you can bring it down to 148. I'm not real good on drag, or 147. Let's see if that works. And sure enough, 147 works. There's our last payment. So drag it down and you should have, why do we drag down row 2 and not row 1? Well, because row 1, its formulas are different. Remember, beginning balance we're referencing up there, whereas in second year we're referencing the previous beginning balance. Interest expense, we could have copied row 18 down, but on payment we couldn't, because payment here is a formula. Here we're just referencing that. We could have copied that down. So there's 2 cells on row 1, the beginning balance and the payment, that aren't the same on row 2. But once you get row 2 built, rows 2 all the way down to the end are the same. Now, one thing you do, if you hit your control button and your down arrow, your right arrow, your up arrow, notice how it takes me throughout. It just takes me, what the control arrow does is if there's, it takes you until there's no more data. And then if I do the up, it takes me until there's no more data. There's an open cell there, so it took me there. So it's a great thing. You notice here, it goes down the time because I have a blank cell there. But then when I hit down, so the control works. If you do control shift and the down arrow, then it highlights everything. So sometimes you just want to go to the bottom and make sure your ending balance is 0. Sometimes you want to actually copy something. All right. So let's say I didn't do the interest here and I want to copy this down. Well, I could drag it down, but boy, that's going to take me forever. So an easier way to do it is if you go to this little corner right here and just double click it. Well, what Bill Gates does is he assumes when you double click it that you want to copy this all the way down as long as there's data in this column. So if I do control down, you can see he copied it all the way down to here. All right, so get used to using the control shift, all of that. Control shift, I could capture all of that, do control C and go right and just copy right there if I wanted to. I don't really want to do that, but I could do that. All right. So there's our first problem. If you're having trouble with this and you just cannot get it to work, what I don't want you to do is waste a lot of time trying to get it to work. What would be better would be to give me a call if you're really struggling here. I don't like students spending, saying they spent 20 hours trying to get this working, couldn't get it to work. So if you're 45, 50 minutes into this and it's just not working, put it aside, email it to me. One thing you could do, and a lot of students do this, is they get to a point of frustration and it's just not working. Email it to me, and I can usually in a few seconds see where you did something wrong. A lot of times it's not getting the $10 in place, or it's on the payment accidentally copying this down all the way down, So I usually find what the issue is. So here's your first problem. So this is what you would actually turn in. What I want is for each student to give me their own unique format. Figure out your style. So when I see your Excels, what is it? So what color are you? I love blue, so I'm going to use a dark blue background with white lettering, or I'm going to use gold lettering. So however you want to do it. So set up something so it's your unique look, and then you just turn this in. You don't. On this problem, this is it. This is all you need. You're going to see on a few other problems I ask other questions, and so you'll have to figure those out. So there are some questions where I have not fully developed them, but I've given you 80% and you have one last question to answer. We might, probably in one of our live Zooms, I'll give you a little help on those extra ones. All right, so that's our first problem. There's problem one. So set one, problem one. So now what we want to do is, just like we did before, we want to copy A10 through C13, Control C, and let's go over to the next sheet and we'll copy that on line 10. We have another problem here. You can snip it if you like. Just copy that in so you can see it. Or you can do it like I did with the HMC. So however you want to do it, so you have the problem there. I'm going to do something here. Ignore this right now. I'm just doing this to help us see things a little bit better. So a lot of this formatting thing I'm doing now is simply so it's a little easier to see. All right. So let's look at this problem. This guy he has an idea. He wants to buy a car, but he doesn't want to pay interest to the bank. He'd rather pay interest to himself. So what he's going to do is, rather than buying the car today, he's going to buy it in 5 years, and he's going to make payments into his savings account as if he was making loan payments on an auto loan. And then at the end of 5 years, he'll have saved up the money to buy the cars. So he's going to set aside money for 5 years. So this is a portfolio. He's investing. He's saving. He's not saving for retirement, but he is saving for something. So it's a future value type of problem. He figures that as long as his portfolio earns more than the inflation in car prices, he'll come out ahead. So he wants to buy a car that costs $28,000. Well, that's in today's dollars. And he expects the price of this car to appreciate at a rate of 2.5% per year. So the two formulas that we need here are these two formulas right here. I'm going to bring them over so you can see them. So we're going to use that. He expects to earn 6.24%. He's going to invest weekly. All right. So this is weekly, and this is number of weeks. So what is his rate? It's going to be 0.0624, which is a really high rate. He must be a really good investor. And it's weekly. There's 52 weeks. So there's that formula there. 52 weeks. So his weekly investment, he'll make 0.12% each week. And then how many weeks is that? Well, he's going to do this for 5 years times 52. So he's going to do this for 260 weeks. So these factors are already fine. In this case, we're having a future value. So now what is his target? Well, here his target is he wants a car for $28,000. But that's not really his target. So let's look over here. His target is $28,000, but he expects this car to appreciate 2.5% over 5 years. So we're going to use that formula, the present value times 1 plus the inflation rate raised to the 5th. All right, so we're going to take $28,000 times 1 plus 2.5% raised to the 5th So the car he wants to buy, he thinks in 5 years, will actually cost $31,679.43. All right, so there's your target. If you bought the car today, it would cost him $28,000. But if he waits and purchases it in 5 years, he'll need an additional $3,600. But he'll invest his own money and make much more than 2.5%. So he'll end up ahead, rather than paying the bank interest. And I actually recommend you do this. I had one car that lasted a really long time. And so while I was waiting for that card to essentially dissolve, I just kept making my loan payments, but I made them to my savings account. And so when that car finally died, I had plenty of cash in the bank to go out and buy a new car for cash. And all that interest was my interest. I got to pay myself interest rather than paying the bank interest. And once you do that for the rest of your life, once you can get one car that lasts 10, 11, 12 years, if you have a loan for 5 years and the car lasts for 10 years, then you have 5 years you keep making the loan payment to yourself rather than to the bank. And at the end of 10 years, you're now set up for the rest of your life making loan payments to yourself and buying cars for cash. It's kind of a fun thing to do. So anyway, I recommend you do it. So here, let's set up our columns again to make them 15. It's going to make it hard to read up here, but that's okay because we don't need all of this. This is a problem that it's hard when I'm doing this in a class to get all this to line up well. Let me change the format cell. I should have been using top instead of center, but so there's that problem. We should be able to read it all. Still a little too large, sorry. All right, so hopefully we got everything, we can read it. We don't really need to see the problem anymore, but we have it. All right, so remember over here we had time, beginning balance, interest expense, payment, and ending balance. We're going to have almost the exact same problems here. I went down to line 16 here. Let's go down to line 17. Just give me a little bit more room to work with. And so our line 18, let's actually go down to line 18. So we'll put time there. We'll put beginning balance here. Now remember, in the previous problem we had interest expense. Here it's not interest expense, it's interest earned, because this is our money. We're earning interest. Remember, in the previous problem we had the payment, but this is not a payment, it's an investment. And then we have ending balance. But you notice they're almost exactly the same. The only difference is the interest is earned instead of expense, and it's an investment rather than an expense or a payment. And so let's make them all 15. So let's center them, put your trademark in there, center them, bold, all that kind of stuff. All right, so again, time we're going to do just like we did before. We'll start with 1, and then we'll do equal that plus 1. So that's no different than before, exactly the same formula. The beginning balance here is 0. Because, and I'm going to hit the dollar sign up here, because we just know that we haven't invested anything yet. We're starting from scratch. So there's our beginning balance. Kind of depressing, disappointing, but it's going to build up. Our interest earned is the exact same formula we did before. No difference here. We're going to take, just like we did in the previous example, we're going to take equal beginning balance times the rate, and again we want to lock that in. You want to have $ B times $10. You notice it's the exact same formula we had over here. I mean, we're one line down, but 18 times B10. Here it's going to be the same formula, except for we're one row lower down. So B19. Now it's 0 because we didn't have anything. So we didn't have anything invested, so we started with that. So for that period, we didn't earn anything, and at the end of the period, make our first investment. Well, what is our first investment? So here's the formula right here. So our first investment, so here we know our target is 31,679.43. That's going to equal our investment times the future value interest factor and annuity. So that's what we're looking for right here. So that means that our investment is going to equal 31,679.43 divided by our future value interest factor of annuity. Essentially, it's the same formula we had before. Remember, on the loan, we took the loan amount divided by our present value. Here, we're going to take our target. How much do we want to save? Divided by our future value. And there, and I'm going to hit the dollar sign on that. So we'll invest $103.90 every week for the next 260 weeks. Now, our ending balance, remember over here, our ending balance was beginning plus interest minus payment. Here, all we do is we take beginning balance plus interest earned plus the investment. All right, let me put these formulas up there. All right, so there's all of our formulas. Can you guess what the beginning balance is going to be? Equal, go over and get your ending balance over there. So you just equal your ending balance. Interest earned, again, we can just copy that down if you locked it in. Now this is real depressing. The second week you'll earn 12 cents. But okay, that's fine. And your investment, you just equal the previous one. We want to invest the exact same amount each time. So you just equal the previous. Ending balance, you can drag that down. So again, we come over here, so we do Control Shift right. I don't like using the drag. I like to do Control C to copy, hit my Shift button, and page down. We need to go down 260 weeks. Week 1 was on line 19, so we need to go probably to 278. So I hit the Shift and I just page down until I get to 278. Getting close. Hit Enter. And remember, I can do Control down. And look at that. 31,679.43. What were we looking for? 31,679.43. Control down. You can see that we got exactly what we needed. All right. So again, you start with time 1. Your beginning balance on a future value problem is usually 0. It's possible he could have had 10. Maybe he had an uncle or aunt gave him $10,000. But if you do that, you have to change the problem some way, because if you put $10,000 here, you're going to end up with a whole lot more than 31,000. So in that case, it'd be a good one to test to see if you can come up with the right answer doing that. But it's a little bit different problem. So your interest earned is just exactly the same as the present value problem. It's beginning balance times that weekly interest rate. Your investment is the same formula, except for you take your target and you divide by the future value factor, not by the present value factor. And the ending balance is different in that we add everything across. We don't subtract the investment. And then the next line, you just take the previous ending balance. The interest is the same. You just copy that down. The investment, you just reference the previous investment. Ending balance, you can copy down. Then you copy the whole thing down. And your very last line should show 31,679.43. Well, let's think about this since I brought this up. Let's say someone comes in and says, "I'll give you $10,000 today, and help you save toward this car, and you want to invest enough to make up the difference." So how would you do that? So what we can do here is we know we have $10,000, and we're going to make 1 plus 0.12 for 260 weeks. So we expect this to be, that $10,000 to be worth $13,658.99. All right. So if we put $10,000 here, it will be worth $13,658.99 down here at the very bottom. So what does that tell us then? That tells us what we need is this $31,679, but we don't need this $13,658.99. And then if we put 10,000 here, let's see if it works. We have 10,000 here. What did we want before? We wanted to equal, looks right to me, doesn't it? We want it to equal 28,000 times 1 plus 2.5% raised to the 5, 31,679.43. So that works. So I don't know if any of y'all, if you want to, it's really good on these type of problems to figure out if you can figure it out. So someone says, I'll give you 10,000 bucks. Say, okay, well, 10,000 bucks, and I'll make my return on that, my 6.24%, but 0.12%. I'll make that, so that's going to be worth 13,658. So I don't need 31,000. I only need 18,000 because I'll make 13 off the 10,000. So you're going to get some problems. Your last two problems ask the question not on the investment side. I just want to show you some things you can do on the investment side. Not on the investment side, but on the loan side. So you have to think about this. The loan side, you're going to get the question of what if you all did this through your credit union, and your credit union charges $572. What if instead you go to the car dealership and they say, we're going to charge $650 for the interest rate? You say, well, that's higher than my credit union. They say, yeah, but if you borrow through us, we'll give you a discount on the car of $2,000. Now, how would you figure that out? So I'm not going to give you the answer to that because you have a problem to do that, but just think through it. You really have two problems. You have one, which is the credit union that you've already set up, and you want to compare that to the auto dealer with a higher interest rate but with a lower target amount. So you essentially do the entire problem all again, but instead of using $78,000, you use $76,000. Instead of using 5.72%, you use whatever rate the auto dealer has. So then the question is, how do you know which one charged you less? And you know exactly what you're paying. It's the payments. So all you have to do to compare those two is sum up your payments and compare them, and whichever has the lower payments is the better deal. All right, so I just say that maybe in our live stream, maybe I'll find some other kind of gee whiz questions that you can do. So the reason I throw these things out there is to see if you're learning the basics, but if you really know it, then if I throw a curveball at you, you should be able to make an adjustment to somehow be able to change what you're doing and get the right answer. On the final, I might give you one little tricky question. I'll give you some real basic ones, but I gave you one little tricky one just to see who are those students that are really getting to critical thinking on this and understanding it. So what have we done here? We've done set 1, problem 2. So you have 2 problems set up. You should be able, if you built these, you should be able to use these to work the other problems, just like I did it. Just build them from scratch. Or if you want to, if you have another loan problem, you could copy this entire thing and paste it to another sheet and just change it for your numbers. You don't need all these formula things here. You can get rid of those if you like. You don't need that. You don't need this stuff over on the side. You don't need to tell me all this stuff. Just have it set up here. I'm doing that. Give me, set it up with your colors. You can even, if you want to, find your own fonts. Do something so I can see, oh, that's Jacob's approach, that's Amanda's approach. Find something. I don't really like that. Boy, that's kind of hard to read, but find something that puts your personality on there and shows you, shows the professionalism. You want this, imagine you're going to send this to your boss. So make it look professional and clean. And mine's a little messy because I have all these formula things over on the side. All right, so we've worked 2 problems. You're seeing my approach. After you watch this video, if you have some issue with the way I'm doing things, then definitely let me know, and I'll make changes. It'd be hard to make changes because I probably have already made the next several videos, but there's some changes I could go back and make, and maybe add a kind of a follow-up video if I needed to. So not quite an hour today, but if you hit pause a few times, it probably went more than an hour for you. So we'll stop it there. And what we'll do next time is do some other applications, because there's a lot more applications of this that I think are incredibly powerful and very, very interesting.